This is a problem in linear programming. This problem talks about the minimization of an objective function, and the objective function is depending on the two variables x1 and x2. Our job is to find the value of that value of x1 and x2 for which this z will be, the objective function will be minimum, subject to certain constraints, and the constraints are here given as x1 plus x2 is greater than or equal to 1, 2x1 plus 3x2 is greater than or equal to 2, and that x1 and x2 are non-negative variables. I have talked about this in one of my videos, wherein I have said that in a linear programming problem is about the finding the optimal solution of an objective function subject to certain constraints, and the objective function depends on certain decision variables, and the decision variables can never be a negative quantity. That is, x gray, both are non-negative. This is a small introduction about the linear programming problem. A linear programming problem is nothing but optimization of objective function subject to certain constraints. This is what we should know. And a linear programming problem can be solved using graphical method and also simplex method. Graphical method is one where there are only two variables are involved, but in the case of a simplex method, using of simplex method, two or more variables can be there, and that any number of constraints can be there. But in graphical method, while you use, necessarily there cannot be more than two variables, but any number of constraints, because you have to draw the graph and identify the feasible region, which is the very much required. That is, if there are a lot of constraints, finding the feasible region will be difficult. Okay, so with this small introduction about the linear programming problem, and another point I want to emphasize here is that we call this as a linear programming problem because none of the variables in the constraint or in the objective function are more than 1 degree. That is, the degree of it is 1 only. If any one of this happens to be anywhere, any square, for example x square coming here or in the constraints, it will be called as a non-linear programming problem, which can be solved if we have got different methods of solving it. Now let us stick on only to this. Okay, now here you can find that is a dual simplex method. Actually, this dual simplex method is just right opposite of simplex method. Simplex method I will take on different occasion, but having taken this now, I'll explain how this is done. Simultaneously, I'll tell you something about the simplex method also. Simultaneously, I will tell you. Okay. Now, here you see that whenever you come across problems in minimization, better change it to maximization. Particularly in this dual simplex method, any problem that is given as minimization must be changed to maximization. How that is done, I will tell you now. See, min of z is equal to minus max of minus z. That you can write it as minus max of z star minus z star. Now, instead of solving this min of z, I will solve for max of z star, where this z star is nothing but minus of this z. Know that, forget this min, z is equal to 3x1 plus x2. So you take the minus of z. So what does it mean here? In this particular case, min of z is equal to minus max of minus z is minus 3x1 minus x2. Now you have to maximize this function. This I will call it as z0. So z star. So what we are having is that max of z star is equal to minus 3x1 minus x2. In the sense that z star is this, you are going to maximize that. You are going to maximize that. After finding the maximal value using the dual simplex method, multiply by minus sign so that you will get the minimum of z. Are you clear with this? So minimum of z is nothing but minus max of minus z. See, minus z I would be. So you solve for this now. Solve this equation subject to the same constraints. See, this has to be solved subject to the same constraints. Get the value of the maximum. Multiply that by minus sign, you will get your minimum. So this is the art of doing this particular problem, or the procedure to do this problem. Now let me come to the problem now. Now I'll rewrite this. So I hope that you have understood this particular. I can give you a lot of examples to make you understand this, but because I feel that you without so much of explanation itself, you will be able to understand this. That's why I skipped that small part. Still, if anybody wants to know more about this, you can write in your comments so that I will be able to reply. Okay. Now let me come to this. So take this. I will take this now. So I will write here min of z is equal to 3x1 plus x2 implies that it is max of z star is equal to minus 3x1 minus x2. Now I'll write subject to same constraints, but these constraints do not keep it as if it is a maximization problem. Try to remember that the constraints will be less than or equal to, minimization greater than or equal to. Here you keep all the constraints as less than or equal to. Are you able to catch? So given a minimization problem, change it to maximization problem using this technique. Then write the constraints, and if there be any greater than or equal to constraint, change it to less than or equal to constraint. Now how will we change this? Throughout multiply by minus sign. Minus x1 minus x2 is less than or equal to minus x1. Minus 2x1 minus 3x2 is less than or equal to minus 2x1 x2 greater than or equal to 0. Now I have changed the problem completely, in the sense minimization has been changed to maximization and the constraints have been brought to less than or equal to constraints. Now I will write this. Now you have to bring this to I have to change this by adding the slack variables. See here, what I want to tell you is that now I am going to use the simplex, that is the procedure for solving it using the simplex method. So here I have to change this. I have to bring it to the equality form, in the sense that I will write this as max of z0 is equal to minus 3x1 minus x2 subject to, here what I do here is that minus x1 minus x2. Now you have to make this equal to, if it is less than, say for example you have got 4 is less than 5, so 4 plus 1 is equal to 5. So this small increment has to be put so that it will be equal to the right hand side quality. So what I will do here is that I will add some s1. S1 is a non-negative slack variable. When it is less than or equal to, slack must be added. when it's greater than or equal to, your surplus must be subtracted. Here in this case, it is less than or equal to, so add a slack. So S1, I'll write it here, this is equal to minus 1. Similarly, what is the next one? Minus 2x1 minus 3x2 plus S2. Here again, it is add a surplus slack variable minus 2. And better you put whatever is missing, you put it as 0s1, here 0s1. So why I have given a space here is that s1 plus 0s2, here 0s1 plus s2, I have added to this s2 and I have added to this s1 so that it is equal to minus 1. Now I have brought two slack variables. S1 and S2 are slack variables. S1, S2 are called these slack variables. And now what is that you are having? X1, X2, S1, S2 are all greater than or equal to 0. All are non-negative and they are greater than or equal to 0. Now, after then, so first step, change it to maximization. Then bring it to this form, homogeneous form like this, and you see that max of z star is equal to minus 3x1, and you put here plus 0s1 plus 0s2. So bring it to this form. Now therefore max of z star is equal to minus 3x1 minus x2 plus 0s1 plus 0s2 subject to constraints minus x1 minus x2 plus a slack s1 is equal to minus 1, minus 2x2, minus 3x2, plus the slack s2 and minus 2. S1 is missing, port S2 is missing, 0 S2. S1 is missing, so you write this because this will help you to avoid certain oversight mistakes we are likely to come across. So that is why I have put like this. Having put in this, now this is what we have got. Now we have to put it in a table, iteration table. Iteration process is a process in which you repeat the process until you get a solution for that. The coming of solution will be made known to you by certain conditions you impose on a certain variable. All those things I will tell you. As and when I proceed, I will tell you what it is. So our job is to now put it in a table and then start solving. Now, let us, for which, whatever it is, I want a initial solution, a basic solution I must have. Okay, that means without anything, any solution in hand, I cannot proceed. If I have a solution, a raw solution, I can improve on the solution. So our iteration process is the one in which you find a damn solution you find. After then, using the proper method, you just go step by step and then finally reach the correct solution. So for which I require a basic solution. Okay. For which, how do you find that? You just take this. How many variables are there? Variables, number of variables. I'll write here. Number of variables. N is equal to how many variables? 1, 2, 3, 4. Okay. Okay, I'll call this as 1. Okay. Now, number of equations. Number of equations, M. See, there are only 2 equations. 2. Subtract, you will get 2. So, you get, now you make 2 variables 0. Those things, particularly these decision variables, make them zeros. Don't take the slack variables as zeros, don't take. Only you have to take the decision variables. Now, so you take this, x1 is equal to 0, x2 is equal to 0. So when you substitute here, x1 is equal to 0 and x2 is equal to 0, your solution will be s1 is equal to minus 1 and s2 is equal to minus 2. So what is that you get here? So x1, you want an initial basic solution. I want an initial basic solution. See, what is that solution? Solution means finding the value of x1 and x2. Understand that first. Solution means finding the values of x1 and x2. Now, I will take the solution of x1 and x2 as zeros. So, if I put x1 x2 0, then you see the s1 is equal to minus 1 and s2 is equal to minus 2. Now, what you have to understand it here is that this S1, S2 are very, very raw solutions. Using that, I will improve and get the final solution. And here you see that they are all negative. A solution can never be a negative quantity. I'll tell you here it cannot be negative. You will not get, because we know that here all are what? Non-negative, but you are getting what? A negative solution. That means they are called infeasible solution. They are called infeasible. So S1 and S2 or I am getting infeasible solution. I should use a procedure, iteration process to arrive at the what? The final solution. Not S1 to S2. S1 to S2 I don't want. I want the values of X1 to X2. Now using a raw solution as this, S1 is equal to -1, S2 is equal to -2, which are infeasible solutions. This is infeasible, I write here, infeasible solution. See, S1 is equal to -1, S2 is equal to -2, infeasible solutions. So you see that they are infeasible solutions. Using the infeasible solutions and using the method of iteration process, I try to get the final solution. This is what we are going to do now. Okay, so have this in your mind. Let us start preparing the table now. Now let me write here. I'll rub off all this. See, I'll write here CB, YB, XB, CJ. You will ask me what are this? CB is a cost column. In the sense this YB is nothing but your basic solution, initial base. It is a, see, it's a negative infeasible solution. So you see that this S1 S2 have become the basis. Basis means they have formed the solution. So you write it as S1 and S2. And here you got X1, X2, S1, S2. These are the four variables that are coming in the problem. And Cj refers to the coefficient of X1, X2, S1, S2 in the objective function. This is your objective function here. What is the coefficient of X1 here? -3. What is the coefficient of X2 here? -1 and 0, 0. So this XB refers to the variables. Cj refers to the coefficient of the variables in the objective function. So that is what I have written here. Then this YB column refers to what? The basis, S1 and S2, the first basis that you get. After then, you see that here, these S1 and S2 are all the basic variables. Now we will go on finding the non-basic variables. That is, we're using the iteration process. I'll go for the non-basic variables. Which are the non-basic variables? X1 and X2 are called the non-basic variables, and I should find the value of X1 and X2. That is my motto. Okay. Now S1. Now S1 and S2. What are the coefficients of S1 and S2? Here, so what is the value of S1 and S2 in CG? See, S1 value is 0 and S2 value is 0. So the CB cost column is nothing but the value of S1, the coefficient of S1 in CJ, in CJ, S1, what is the coefficient of it? 0. S2 is what? 0. So these two zeros have been taken from here. -3, -1, 0, 0. So you put value of S1 as 0, value of S2 as 0. Then write this equation. What is the first equation? It is -1. Your XB column is -1. So XB, this is your XB column. -1, then write this equation. -1, -1, 1, 0. So how do I write this? So this YB is nothing for basis, and CB is the cost of S1 and S2, which are nothing but the coefficients of S1 and S2 given in CJ. and this xb is nothing but right hand side value minus 1, and x1, what is the value of x1 here? Minus 1. What is the coefficient of x2 here? Minus 1. What is the coefficient of s1 here? 1. And what is the coefficient of s2 here? 0. Similarly, you write the next one. What is the next one here? It is minus 2, and it is minus 2, minus 3, 0 and 1. So these are the things that we have got. So I have taken all these values and I have put in the for the iteration 1. This is iteration 1. So I have put here. So now you see that you have to be very carefully doing the problems, because numerical values are coming. There is every chance that you in subtraction or multiplication, division, that in those things you are likely to go wrong. So you have to be very careful. Then only you will arrive at the correct answer. Otherwise you will end up in struggle. Okay. Now, so let us now try to put this. Then I put like this. So then I write this as Zj minus Cj. Zj minus Cj, I will tell you what it is. Zj minus Cj mean Cb, this is nothing but Cb into, here it is nothing but what? Here it is Cb into Xb. See, Cb transpose 0, 0 into minus 1, minus 2. See, 0, 0, you take the this thing, transpose of that, 0, 0, minus. See, first row into first column, 0 into this, 0 into this, so you will get it as 0. You have to understand how this is done. So what is your xb? This is nothing but your x, this is your zb value. So this zb value, below that you put a xb value. This value is got by multiplying 0, 0, that is 0, that is CB transpose dot XB. So you get 0. Then here in this, how do you get here? It is CB transpose into, so I will put this as C1, C1, C3T, CBT, I write here, CBT into, here I will put this as, let me put this as here A1 I will, yes, A1 minus C1. I will put here, see what does it mean? So this is equal to CB is 0, 0 into your A1 is this. A1 it is minus 1, minus 2 minus, what is the value of here? This is C1, this is C2, this is C3, this is C4. So minus C1 is minus of minus 3. So this is 0 plus 3. So what is the value that you get? Here 3. So how do you get the first column, Zj minus each column? So this is your Z1 minus C1. If you apply the same method, here you see that 0, 0 into this is 0. Then take away this minus 1, so you are getting this one. So this is Z2 minus C2. Likewise, if you put this is 0 and this is 0, this is Z3 minus C3 and this is Z4 minus C4. Now, so what is that we are trying to get? You are trying to get the ZB value. ZB value is got by taking CB transpose into XB. This into this, you get this. Is it that 0 into this 0, 0 into this is 0. Then 0 into 1 is this, 0 into 1 is this. Then take away that minus 3, you will get plus 3. So similarly, you will get now Zj minus C1, Z1 minus C1, Z2 minus C2, Z3 minus C3, and Z. You find that none of them is negative. None of them is, that means an optimality condition. What is that optimality condition here? Optimal condition means a condition which is required for an maximum value, the optimal value, maybe minimum or maximum. So this condition has to be satisfied so that what you have got as maximum or minimum. See, that is an optimality condition. So this condition is satisfied. How do you write this? So this is equal to Zj minus Cj. This is required. This condition must be required in order to get a value as maximum or minimum. Are you able to understand? So this condition is satisfied. And another condition that has to be satisfied is you must have all feasible solutions. Here XB is called the feasible solution. See, solutions come here. Here your solutions are here. Your solution XB or your solutions. XB or solutions to problem. XB's or solutions to problem. Here I will write here. To linear programming problem. LPP. Linear programming problem. So XB gives you the solution to the problem. Values of the non-basic variables. And this Zj minus Cj gives you the optimality condition. So optimality condition must be satisfied, and then your XB value should be feasible. Feasible in the sense none of them should be negative. See, XB are all greater than or equal to 0, and Zj minus Cj all greater than or equal to 0. This is a condition. This is called the optimality condition. XB value greater than or equal to 0 means feasible solution. Here it is feasible solution. This is called optimality condition. So this is called optimality condition and this is called a feasible condition. So only when these two are satisfied, we say that the problem is solved. Otherwise the problem is not solved. If it is not solved, that means you ask for the question. You ask yourself the question. Has the optimality condition satisfied? Yes. Has another condition, feasibility, satisfied? No, it is not satisfied. In which case, move on to the next step of finding the solution. Are you able to understand? That means what? Here S1 and S2 are happen to be solutions, which is not at all true. I want a non-basic x1 or x2 to be my solutions. So I have not got that. So I will pause on to the next step using a particular method called the iteration method. Nothing more. Okay. Now, let us know how to find. See, let us see. So these are the things. So what are that? The problem is not over. Problem not over. Not over. Problem is not over. Not over problem. Not over because feasibly solutions are infeasible. But this condition is satisfied, but S1 is equal to minus 1, S2 is equal to minus 2. Therefore, the feasibility, the solution is not arrived at, and we have to pause on to the next step. What is the next step? I will write here. See, I require the space, that is why I rub off all this. Now, first, what you have to do is find the leaving variable. Finding the leaving variable. See, find the leaving variable. The leaving variable in the sense we have got the infeasible solution. So we have to find that variable which will give us a solution to the problem. That variable, that means what? It may be a basic variable also. But I go for the method in order to find the solutions, which is nothing but finding the values of x1 and x2. Now, since the values are infeasible, I try to find, I send a infeasibles out and try to bring a feasible solution inside. Okay. So here you see that both are infeasible. So infeasible in the sense that minus 1, minus 2. You choose the maximum negative. What is that? Which is maximum negative here? Minus 1, minus 2. Don't say minus 1. I am not asking about the values. I say that minus 2 is the maximum negative. See, minus 2 is max negative. It is not by negative value, it is not by value, it is not greater than minus 1. Minus 1 is greater than minus 2, but maximum negative means minus 2. So you choose that row. So S2 is leaving. S2 is leaving. Now you want to find which is, so 1 is leaving means you are going to work out the problem with the two variables. You are sending one variable out, so you must try to bring in place of it, replace that by another variable. How to replace that? Find the ratio of, see, Zj minus Cj divided by Akj, and Akj is strictly less than negative. Find the ratio. What is the meaning of this Zj? These are called Zj minus Z1 minus C1. So Z1 minus C1, Z2 minus C2, Z. And this Akj refers to the, see here, what is your K? K refers to the row. And this, which is the row that you have chosen here? Your key row. This is called your key row. This is called your key row. So this is your key row is this. So here it is the second row. J refers to the columns. So for every in the K column, you find what you try to find out what are these AKJ. That means in that column you find out what is the element in jth column. For example, don't take this XB here. XB is not required, only here. Here you see that AK1, this is my row. In this, the first column is minus 2, second column minus 3, third column 0, fourth column 1. And it is given that choose that AKJ which is strictly less than 0. That means you have to don't take this, because this is positive quantity, this is 0, don't take that. Only take the values of the negative, only choose that AKJ which are negative. Here you see that AK1 is minus 2, AK2 is minus 3. So what is that you will get here? So it will be a set. I'll write here. Take this, it is minus 2. See, minus 2 divided by minus 1. Minus 3 divided by minus 1. That is equal to 2 and 3. So you are having this 2 and 3. In this, what you have to do is, you have to catch hold of. So what is that we have found? We have found the ratio of Zj minus Cj divided by Akj. Now you choose the maximum. Max of Zj minus Cj divided by Akj, which is equal. What is the maximum of this? 2 and 3. Which is your maximum? 3 is maximum. So corresponding to this E3, whichever is your column, that variable is the entering variable. Or you catch what? Can you understand the language here? You find this, you find the value of this. See, I have ultimately got this 3 as my maximum of the ratio. 3 refers to which column? See, now this I am taking 3. It refers to which column? It refers to column of x2. So x2 is the variable which is going to come in, and s2 will go out, x2 will come inside. So what will happen here? So this is what you'll have. So this is key column. So this is your key column. So this is your key column and this is your key row, and what is that you get here? This is your key row. Here I will write here. So this is your key row and this is your key column, and you find that this is so this is your key element. Now what is that we have achieved? So the first step that you have to do here is that after all those things, prepare this iteration 1. Do this. you choose the infeasible solution, you choose the maximum negative. Don't compare values, take maximum negative. So this is maximum negative is what? -2, that is your key row. And the column means you find this ratio is that j minus kj divided by akj. Akj refers to kth row. Kth row is your key column, key row, and j refers to the column values. Here you see that here is z1 minus c1. Here I have taken, what is the value of this? It is here it is 3. Here I have written it wrongly. See, here I will write it here. I rewrite this. That is equal to, see here 3 minus 2, sorry, 3 minus 2 and 1 minus 1. So this is equal to minus 3 by 2. It is minus 1. I am sorry, yeah. So 3 divided by minus 1, sorry, 3 divided by minus 2 and 1 divided by minus 3. Now this is equal to, minus 1.5 minus 1. So max of 1.5 minus 1. What is the maximum of minus 1.5 and minus 1? Which is your maximum? See, minus 1. Now you have to compare the values. Which is maximum here? Minus 1.5 or minus 1.1? 1 is the maximum because this is bigger. So this is equal to your minus 1. Now this is minus 1 and you referring to this corresponding to this minus 1 is your x2 column. That is correct. That is not wrong. That is correct. So what is that I have done here? z1 zj minus cj is 3 divided by this minus 2, 1 divided by minus 3. See here, 1 divided by 3 divided by minus 2, 1 divided by minus 3. We should go wrong very carefully. So this is minus 3 by 2 minus 1 by 3. So this is equal to, so I want the maximum of minus 1.5 minus 0.33. You can do it in any way you want. So minus 3 by 2 minus 0.33. Now which is the maximum of this? Naturally 0.33. Negative value smaller will be greater. So you say that it is minus 1.5 minus 33. So corresponding to this is the 1. So our again x2 is the what? It is the entering variable. So how do you find this? z1 minus c1 divided by akj, 3 divided by minus 2, 1 divided by minus 3. On simplification you get minus 1.55 minus 0.33. Take the maximum of the two values. Maximum is 0.33, against which the variable is x2 and that variable is entering variable and leaving variable is s2. Are you able to understand? Now, so here be careful because if you don't do it correctly, everything will go wrong. So you have to be very careful. Okay. Now let us take this. So your key row and key column, everything I have got here. Everything I have got here. Now I'll write new pivot equation. New pivot equation for which what is the entering variable? So it is the x2. Your x2 is the entering variable and new pivot equation will be we are forming a new pivot equation. Using that I will form the other equations. Okay. Now this is x2. Now you take this. Now you write this. What are the elements here in s2? Minus 2, minus 2, minus 3, 0, 1. What is the key element? Divide throughout by my key element. Minus 3, minus 3, minus 3, minus 3, minus 3. That is equal to what? So x2 is 2 by 3, 2 by 3, 1, 0, minus 1 by 3. This is your new pivot equation. Now, you have to change all other equations. Here you see that Zj minus Cj. S1 is old. So, change all other equations. Now, old S1. What your old S1? Minus 1. Say start from XB. Minus 1. Minus 1, minus 1, 1, 0. Now, what is that AKJ or key element in this particular this thing? So, here it is minus 3 means this minus 1. See, minus 1, this is okay. Now, what is that? Here you find that minus 3 is the key element. For this particular S1, you may call that as a key element here, or it is the AKG value. So what is that minus 1? So minus 1 is your AKG. So what is that you will do is take away minus 1 into new pivot equation. This is new pivot equation. So what is that you will do? Take away, multiply this minus 1 with new pivot equation. So minus 1 into 2 by 3 is minus 2 by 3, minus 2 by 3. It is minus 1, then it is 0, then it is plus 1 by 3. Subtract everything. Now you go for subtraction. So what is that you will do? Multiply this my key element. The key element here is minus 1 with the new pivot equation and do. Now you subtract. See, when you subtract, this will become plus. So minus 1, it will become minus 1 plus 2 by 3. So minus 3 minus 1 by 3. Then here again it is minus 1 by 3. This is minus 1 means it will change 0, 1, minus 1 by 3. So this is your new S1. This is your new S1. Now I'll write here. So this is what we have. Now old Zj minus Cj. What is your old Zj minus Cj? 0, 3, 1, 0, 0. Here what is that you will do? What is the key element here? The key element is here 1. For this it is 1. Take away 1 into new pivot equation. New pivot equation is what? 1 into 2 by 3, 2 by 3. 1 into 2 by 3, 2 by 3. 1 into 1 is 1, 0 minus 1 by 3. New is a j minus cj. Now you subtract minus 2 by 3. 3 into 3, 9, 9 minus 2 is 7. It is plus because it is 3 minus 2 by 3. It is 7 by 3. This is 0, this is 0. This is 1 by 3. So this is what you have. Now I have changed all the equations. Here I have found the new pivot equation. I have changed this equation S1 and I have changed this. I have found the new equation for Zj minus Cj. Now the second iteration I can write. Now what is my second iteration now? So second iteration I'll write here. Now come to this. Now you write this x2 here. You write x2. What is the coefficient of x2 here? Minus 1. Because CB is nothing but the coefficient of x2. And write the equation here. What is your xb value here? Your xb value is this. 2 by 3. Then 2 by 3. Then 1, 0, minus 1 by 3. Then this I have written. Then come to this S1 What is the coefficient here? 0. Write this equation, minus 1 by 3. Minus 1 by 3. Then 0, 1, minus 1 by 3. Put a column, this thing right like this. Then Zj minus Cj. What is it? Minus 2 by 3. Here it is. Then it is 7 by 3. Then it is 0, 0, 1 by 3. So these are the things that I have got here. Minus 2 by 3, 7 by 3, everything. So I have formed the iteration 2. Now you have to repeat the process again. There is nothing to big thing that I am going to do in the second iteration. I will use the very same method I have taught you in the first iteration and arrive at the new pivot equation, new equation and everything, provided if it is infeasible or the conditions of optimality is not satisfied. I will tell you what it is. Now you just see here. See, now you find Zj minus Cj all greater than or equal. See, Z1 minus C1, Z2 minus, all are greater than or equal to 0. That means optimality condition is satisfied. Now, what is the value of this x2? 2 by 3. What is the value of this s1? Minus 1 by 3, but minus 1 by 3 is an infeasible solution. So again, since the solution is infeasible, you have to repeat the process. Here, see, was satisfied. But S1 is equal to minus 1 by 3, infeasible. Therefore, repeat the process. Therefore, repeat the process. Now, I have to repeat the process to get the solution. What is that you will do? Find out the leaving variable. Now, which is your leaving variable? Here, this is the only negative value of that. If there are more than one negative values, I told you compare and take the maximum negative. But here it is the only negative value. So, your key row is this. Key row. And which is your key column you will take? There are two things. See, what is your Zj minus Cj divided by Akj. What are those things that you will have? See, 7 by 3 divided, see right here, 7 by 3 divided by minus 1 by 3, 1 by 3 divided by minus 1 by 3. So what is it here? 7 by 3 divided by this 1 by. So what is that you will have? 3 will go to the top and you will have it as, it is minus 7 and it is minus 1. See, 3 will go to the top, minus 7. So max of minus 7 minus 1 is equal to minus 1. So which is your maximum here? Minus 7 or minus 1? Now you have to compare the values. Minus 1 is greater than minus 7. So this is the column which is going to come inside. Entering variable. S2 enters. S2 enters. And S1 leaves. So this is your key column. So your key column I have found, key row. Now this is called your key element. This is called your key element. Now let us form the new pivot equation. I write here new pivot equation. Which is the entering variable? S2 is entering. So write that. And what is that here? Which is the key element here? Minus 1 by 3. Divide. See, S1, what does it mean? S1 divided by minus 1 by 3. That means take this S1, throughout divide by minus 1 by 3. So the first one is 1, the second one is 1, third one is 0. It is 1 divided by minus 1 by 3. 3 will go to the top. So minus 3, minus 1 by 3 divided by minus 1 by 3 is 1. So this is my new pivot equation. You know how do I get this? Take this S1, divide throughout by minus 1 by 3, you will get the answer. So this is what I'll. So keep this. Now, old What is your old x2? You're hiding it, x2. What is your old x2? 2 by 3, 2 by 3, 1, 0, minus 1 by 3. Now, which is that AKJ element or K element in this? With regard to this is the key column. So, with regard to this is your. So, tick that x minus 1 by 3. Now, minus 1 by 3 into new pivot equation. What is that? Minus 1 by 3 into 1. See, this is what you have. Minus 1 by 3 into 1. Minus 1 by 3. Minus 1 by 3 into 1. Minus 1 by 3. Next is 0. Minus 1 by 3. This is 1. And this is minus 1 by 3. Now you subtract. You subtract. What is that you have? 2 by 3 minus will become plus. See, change the sign of the lower term, then add. So it will be 1. Then, likewise, change the lower term, so this will also become 1. This is 1. This is minus 1. This will become 0. Are you able to catch what I am telling here? See, when you subtract, this minus will become change the sign of the lower terms, then add. So this will become plus. So 2 by 3 plus 1 by 3 is 1. Likewise, it is 1 here. 1 minus 0 is 1 here. 0, take away 1 means minus 1. So minus 1. Then this becomes 0. So this is what you have. So this is your new x2. New x2. Now, old is a j minus cj. What is that you get here? Minus 2 by 3, 7 by 3, 0, 0, 1 by 3. Then you write, which is your key element here now? With regard to this is your key element. So 1 by 3. 1 by 3 into new pivot equation. See, 1 by 3 into 1, 1 by 3. 1 by 3 into 1, 1 by 3. 0, minus 1, 1 by 3. Now you do the subtraction. Minus 2 by 3, when you subtract, it is minus 1 by 3. So minus 2 by 3, it is minus 2 by 3, minus 1 by 3, it is equal to minus 1. Always put a line because this is ZB column. And 7 by 3 minus this will be your 2. 7 by 3 minus 1 by 3. 7 minus 1 is 6. So you'll get this is 0. This is 1. This is 0. Have a watch on this. This is your j minus j new. This is your new j minus cj. So I'll write here. Now you find that don't consider this ZB value is totally, that is the solution to the problem. Don't worry about that. Take only Z1 minus C12, Z0 C1. See, none of them is negative. That means optimality condition is satisfied. You know that first. So I have found the leaving variable, then the entering variable, and I have changed the equations. S1 has been changed, x2 has been changed, and Zj minus Cj has been changed. Now I can pass on to the next iteration. What is your next iteration? Iteration 3. So I'll write here. So I'll write the iteration here. So you have to put these newly found equations in the iteration 3. So I'll put here now. Then now you write all those things here now. Oh, here I have got S2 has come. So I'll write this S2. 1 1 0 minus 3 1 x2, this is 0 minus 1. See, x2 I have got here 1 1 1 minus 1 0 zj minus cj minus 1 2 0 1 0. So this is what we have now. So I have written, but I have not done anything. It is iteration 3. I have put all the newly formed values here. So what happens now? So I have put here. No? So let us. And I will tell you, see what we have arrived at certain things. We have arrived at certain things, but we might have gone in addition, subtraction, multiplication or division wrongly. So how are we sure that the table is true and we have got the right one? For that there is a simple check. Go for the check as we have done, as I taught you in the beginning. 0 into 1 is 0. Minus 1 into 1 is, see what is this column, ZB column? It is got by 0 into 1 plus minus, see 0 into 1 plus minus 1 into 1, that is equal to minus 1. So I have got here. Then 0 into 1, 0 minus 1 into 1 is minus 1. Take away this minus 3, that is equal to minus 1 plus 3, that is equal to 2. So I have got this. Then 0 into 0 is 0. Minus 1 into 1 is 1. 1 minus, see what is that you'll have here? Here it is. 0 into 0 is 0. Minus 1 into 1 is 1. Minus 1. Take away this minus 1. Minus 1 plus 1, that is equal to 0. So I have got here. Then 0 into this is 0. Minus 1 into minus 1 is plus 1. So you have got, take away this, you have got plus 1. 0 into this is 0, this into 0, so you have got this way. So apply that idea which I taught you earlier, that you have to multiply this transpose of this column matrix with this what? With xb value, so that you will get this, then this into this, take away 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 this, you will get the Zj. Only when you are getting the correct value as you have got for Zj minus j by the real calculation, your table is correct, your problem is correct, otherwise your everything is wrong. So you have to be very carefully doing the numerical work. Okay. Now, so we have got here everything correct. Now ours is everything correct. Now what is that I have got here? So Zb is your max of Z0. Here I have to put here Z0. Wherever Zj minus Cj, please replace it by Z0 j minus Cj. Because, see, take this is a note. Wherever I have put Zj minus Cj, you must read it as Z0 j minus Cj, because the new variable that we have got is not Z, because it was like this. See, we had like this. Min of Z is equal to 3x1 plus x2. This is not our problem. What we have done is max of Z0 is equal to minus 3x1 minus x2. We are solving only this problem. So our value here is Z0 j minus Cj. So all the values here are what? Here Z01 minus C1, Z02 minus C2. Here it is like this. Z01 minus C1, Z02 minus C2, Z03 minus C3, Z04 minus C4. So this is what I will have. So in this, so you see that So our problem is that here we have got a maximization problem. In this maximization, so ZB is your maximization. So what is your ZB? ZB is maximization of Z0, that is equal to minus 3x1 minus x2. Now what is the value of x2? Here what is the value, this thing you have got here? So this is, we have found it to be what? Max of Z0 is equal to minus 1. For what are the values? Here you have got x2. x1 is missing. So x1 is equal to 0. x2 is equal to 1. So for what value of max of Z0 is equal to minus 1, for what values? For x1 is equal to 0, because this is called your base. This is where you must look. x1, see, x1, x2 is this. For x2, I'll write it here. x1 is missing here, therefore x1 is equal to 0. And x2 is equal to what? 1. So for x1 is equal to 0 and x2 is equal to 1, this is maximum. That means what? Max of Z0 is equal to minus 3 into x1 is 0 minus 1 into, what's the value of x2 here? 1, that is equal to minus 1. So I have got here minus 1 is equal to ZB value. So by iteration method I have got minus 1, and I have verified also. I have got the values of x1 and x2. x1 is 0, x2 is equal to 1. If I substitute the values, I get what? Minus 1. So my problem is correct. Now this is not the solution that I want. I want minimization of Z. So what is that I want finally? So min of Z. What is the min of Z? It is minus of max of Z0. So minus of, what is your max of Z0? It is equal to minus 1. So this is equal to 1. So what is the solution that you have got here? So we have got minimum of Z is equal to 1 for x1 is equal to 0 and x2 is equal to 1. So this is the solution. Solution by dual simplex. So this is called your dual simplex method. Actually speaking, if you take the simplex method, here I have taught you, go by the iteration method in which you find the you find out the leaving variable first, then the entering variable. But it is the opposite in the simplex method. You go for finding the what? The entering variable first, then the leaving variable. Then here you see that we are using certain ratios to find out the here the entering variable here. There leaving variable we will use some ratios. That is, it is actually opposite of what we have done here in the simplex method to get the solution. So this is the method of doing a dual simplex method. This method do not deviate anywhere the principle of doing this problem. You should not deviate. Whatever I have taught you, the methodology of doing this should be strictly followed in order to solve a dual simplex problem. Let me meet you with another good problem in the next in my next video. Thank you.